everyone, so welcome back to the lecture number 19, and in this lecture we are going to solve one question from your NCERT books, that is example number 3. Okay, so let us understand the question. The question is ABC is an isosceles triangle. So as soon as you read the question, you have to draw the figure, right? So it is given ABC is an isosceles triangle, right? Let's say this is the isosceles triangle A, B, C, and in this triangle AB is equal to AC. Since it is an isosceles triangle, so AB is equal to AC. Understood? Now AD bisect the exterior angle PAC. So we have to draw another exterior angle PAC. That means we have to extend which side, so that we will get this exterior angle. Since it is talking about which angle? Angle A. So exterior angle should be formed towards angle A. So we have to extend this side. We have to extend this side. Okay. So that we will get, suppose this point is P. So that we will get PAC as an exterior angle, right? So this is an exterior angle. AD bisects exterior angle PAC. So AD is the bisector of this angle. So it is the angle bisector. Which was the angle bisector? AD is the angle bisector. Of which angle? Of this exterior angle, right? So let's say this AD. AD is the angle bisector of the exterior angle. Angle bisector means it divides the total angle into two equal halves. This is the first half, this is the second half. So you can write this half is equal to this. Symbolically we can represent it. Right? So now do one thing, let us join this D with C. Okay? So now CD is parallel to AB. CD, this is parallel to AB. So this side and this side are parallel. This is given. Okay? Now, from this following data, so we have to prove two statements. First statement is DAC. DAC, this angle is equal to BCA. BCA, this angle. We have to prove it. And second, ABCD is a parallelogram. ABCD is a parallelogram. Okay. So let us prove individually for the first statement. Okay. So here also you can write what is given, to prove, construction, and then proof. Okay, due to shortage of time, I can directly write proof, but you can write given, to prove, and construction. So let's write, no problem. I can also write given. What is given? So it is given ABC is an isosceles triangle with AB is equal to S. Okay. If AB is equal to AC, so according to the theorem 7.2, their opposite angle must be equal. So this angle must be equal to this angle, right? So here you can write ACB angle or BCA angle is equal to CBA angle. We can write it. Understood? Due to theorem 7.2. Okay. Next is AD is the angle bisector of PAC. AD is the angle bisector of which angle? Of the exterior angle PAC. Since it is the angle bisector, it means this angle must be equal to this angle. Yes or no? Yes. So you can write that DAP angle is equal to DAC angle. So here you can write DAP angle is equal to DAC angle. Okay? Since it is the angle bisector, now this is given. So what we have to prove? We have to prove that the first statement DAC angle is equal to this angle BCA angle. BCA angle. Right? And the second statement, ABCD is a parallelogram. Is a parallelogram. Okay, so now let us prove. See, if we consider ABC as a triangle, then PAC is its exterior angle. It is confirmed. So, if ABC is a triangle, then PAC is exterior. We know it. And we know the exterior angle's value is equal to the sum of two opposite interior angles. Okay. So we can write PAC angle is equal to its interior opposite angles. What are the two interior opposite angles of this exterior angle? This angle and this angle. So we can write this angle is equal to BCA plus CBA. Okay. BCA plus CBA. We can write it because exterior angle is the sum of two, here there is no space, okay, interior opposite angles. There is no space, that is why it is very minimized. Right, now can we write PAC? Can we write PAC is equal to this angle plus this angle? The total angle can be written as this angle plus this angle. Yes. So we can write DAP plus DAC in the place of PAC. DAP plus DAC. We can write it. Clear? Is equal to, right, BCA plus. Now in the place of CBA, that means this angle, we can substitute this angle because it is already given, it is an isosceles triangle, so it's this angle must be equal to this angle. So in the place of this angle CBA, we can substitute this angle BCA. Why? Already it is given BCA is equal to CBA. So in this place we can substitute BCA. Right? Here we have to write the reason because BAC is equal to BCA. BAC, sorry, this is CBA is equal to BCA. Correct. So now, in the place of DAP, in the place of this angle, can we substitute this angle? Yes, because AD is the angle bisector and this angle's value is equal to this angle's value. So DAP angle's value is equal to DAC angle's value. Why? Because here we have proved, here we have given DAP, this angle is equal to DAC, this angle. So in the place of DAP, we can substitute DAC plus DAC. Here DAC, DAC. Now in the place of DAP, I have substituted DAC. Now BCA plus BCA means 2BCA. Okay, here we have to write the reason since DAP is equal to DAC. Understood? Now DAC plus DAC is 2DAC is equal to 2BCA. Clear? Now this 2 move to the right hand side. So DAC is equal to 2BCA by 2. 2 cancelled. And finally we have found DAC angle is equal to 2 cancelled out. BCA. Understood? So finally we have found DAC, that means this angle is equal to BCA, this angle. Okay, and now we have to also prove this. DAC is equal to BCA, we need to prove it, and here we have proved it. So you can say yes, now we have proved that DAC angle is equal to BCA angle. Okay, now it is done. Moving to the next statement, we have to prove it, right? So let's prove. So here the second statement is we have to prove that ABCD is a parallelogram. Okay, so this is the point or vertex B. So we have to prove ABCD is a parallelogram. How we can prove? Since from the first statement we have proved that this angle is equal to this angle. See, we have proved since DAC is equal to BCA. Why? By proved. We have proved it in the statement 1. Now consider AD and BC. Since AD and BC, see here, AD and BC are two straight lines, right? And this AC is a transversal line. Then these two angles are known as which type of angle? They are alternate interior angles or no? Yes, they are alternate interior angles. So if you consider AD and BC as two lines and AC as a transversal line, then these two angles are known as alternate interior angles. Okay. So if we consider AD and BC as two lines and AC H transversal, then these two angles are alternate interior. Then DAC angle and BCA are alternate interior. But we have proved what? But we have proved that these two interior or alternate interior angles are equal. Okay? But we have proved they are equal. We have proved the alternate interior angles are equal. And according to the theorem 6.4 after 6.5, if there are two straight lines and a transversal line which intersect to distinct point, and if the alternate interior angles are equal, then we can say these two lines are parallel. So implies this line AD is parallel to this line BC. Okay, so you can write the reason. It is due to theorem number 6.4 after 6.5. Okay, so what we have found? We have found AD is parallel to this side BC. Okay, now these two are pair of opposite sides, so pair of opposite sides are parallel, and initially it is given that CD is parallel to AB. See, initially it is given this CD is parallel to AB. So this side and this sides are parallel. These are also pair of opposite sides and these are also pair of opposite sides. So from this data and from this data, what we have found? We have found that in this quadrilateral, the pair of opposite sides are parallel. Okay. So we can write here we have found the pair of opposite sides are parallel, and we know if the pair of opposite sides are parallel, then this quadrilateral is nothing but a parallelogram. So hence ABCD is a parallelogram. Okay, so now we have proved the second statement that ABCD is a parallelogram. Okay.